All right, let's unpack this. This academic paper on quantum machine learning you sent over.
Yeah, it's wild.
How cool is that? Don't worry, we're not going to like dive into complex equations or anything.
Right. Yeah.
Instead, we're extracting the essence of what quantum machine learning is, why it matters to
Right.
you, the listener, and how it compares to the kind of classical machine learning that you might already know a bit about.
Yeah, and what's really caught my attention is this isn't just theoretical.
Right.
There's actual code in here. People are building this stuff right now.
I know, it's like science fiction becoming reality right in front of us. But before we get lost in the code, let's step back and answer the big questions. What quantum machine learning? Why should you care? And how does it compare to the machine learning we're already using?
That's the mission of this deep dive.
Okay.
We're going to cut through the jargon and extract those aha moments from this pretty dense paper.
Okay. So if we're thinking about quantum computing, the first thing that pops into my mind is qubits, those mysterious things that are supposedly way more powerful than just regular bits.
Think of it this way.
Okay.
You know how a regular bit can be either a 0 or a 1?
Right.
Well, a qubit can be a 0, a 1, or both at the same time.
Both at the same time. How is that even possible?
It's all thanks to this mind-bending concept called superposition.
Okay.
Imagine a coin spinning in the air.
Mhm.
Before it lands, it's not heads or tails, right?
Right.
It's in a state of both possibilities.
Okay, I'm trying to wrap my head around that.
Yeah.
But how does this superposition thing actually give quantum computers their power?
Well, it allows them to perform computations on many possibilities simultaneously.
Wow.
So, like this paper mentions Shor's algorithm, which was developed way back in the 90s.
Okay.
And it could factor large numbers exponentially faster than any classical algorithm. Think about it. This has huge implications for things like breaking the encryption that protects our online transactions.
Whoa, that's both fascinating and a little bit scary at the same time.
Absolutely. And that's just one example. The paper also talks about Grover's algorithm, another 90s discovery,
Okay.
and it can speed up searches through unsorted data quadratically.
Wow.
Instead of looking through like a million items one by one, a quantum computer could find what it's looking for in a fraction of the time.
So it's like having a superpowered search engine for everything.
Exactly. And these breakthroughs, while incredible on their own, are just the tip of the iceberg. This leads us to the truly exciting frontier, quantum machine learning.
Now we're talking. So how does quantum computing change the game for machine learning?
It boils down to this. Quantum computers can perform certain calculations that are practically impossible for classical computers.
Right.
Take the HHL algorithm, developed in 2009. This algorithm can potentially solve systems of linear equations exponentially faster than classical methods.
Okay, but why are linear equations so important for machine learning?
They are the backbone of many machine learning models. Think about training a machine learning algorithm on a massive data set. We're talking billions of data points. That's a huge computational challenge for classical computers. But the HHL algorithm suggests that quantum computers could handle these tasks with ease.
So we're talking about analyzing data at an unprecedented scale.
Right.
That's pretty mind-blowing.
Yeah.
But I'm also curious about this concept of quantum kernels that the paper mentions.
Right.
What are those all about?
So think of a kernel as a way to measure similarity between data points.
Okay.
Classical machine learning uses kernels to uncover hidden relationships in data,
Right.
but these methods can be quite limited.
Right. They struggle with very complex patterns.
Exactly. Now imagine projecting your data into a higher dimensional space where those complex patterns become much clearer.
Okay.
That's what quantum kernels could potentially do. They could allow us to see connections that are simply invisible to classical methods.
So quantum kernels are like these super-powered pattern detectors.
You got it.
That sounds incredibly powerful, but can you give me a real-world example of how this might be used?
Imagine trying to develop new drug therapies. You have a massive data set of molecules and their properties, but the relationships between them are so complex.
Right.
Quantum kernels could potentially unlock those hidden patterns, leading to faster drug discovery and even personalized medicine tailored to, like, your specific genetic makeup.
Wow, that's quite a leap forward.
It is. But it's important to remember that quantum machine learning is still in its early stages. There are challenges to overcome. This paper specifically mentions barren plateaus.
Great.
Essentially, these are regions where the landscape of the problem becomes so flat that training a quantum neural network becomes incredibly difficult.
So it's like trying to climb a mountain, but the terrain is completely flat, and you can't figure out which way to go.
A perfect analogy. Luckily, researchers are actively working on ways to navigate these barren plateaus and make quantum neural networks more trainable.
Speaking of quantum neural networks, are these basically like the neural networks we use in classical machine learning, but with a quantum twist?
You got it. This paper delves into various quantum neural network architectures, but the core idea is to combine the power of neural networks with the principles of quantum mechanics.
And what's the potential upside of using QNNs? Could they actually outperform classical neural networks?
That's the hope. QNNs could potentially tackle problems that are currently impossible for classical neural networks to solve, leading to breakthroughs in fields like drug discovery, material science, and even financial modeling.
Okay, now we're getting into territory that really bends my mind.
Right.
Quantum transformers.
Yes. You're probably familiar with transformers in the context of natural language processing, like the models that power ChatGPT. Well, researchers are exploring the possibility of building transformers on quantum computers.
Quantum transformers. I'm all ears. What could these things potentially do?
Imagine language models that can analyze and understand text in ways that we can't even begin to comprehend right now.
So like a quantum-powered Shakespeare that can write sonnets that would blow the original bard's mind.
Perhaps. But on a more serious note, quantum transformers could have a profound impact on how we interact with and understand information. They could revolutionize everything from online search to scientific research.
This is all incredibly exciting, but I have to ask.
Yeah.
Is any of this actually possible? I mean, it sounds like something straight out of science fiction.
That's the million-dollar question. Remember, quantum machine learning is still in its infancy. There are significant technical and theoretical challenges to overcome.
So it's not like we'll be having conversations with quantum AI assistants next year.
Probably not. But the progress being made is remarkable. The fact that we're already seeing code demonstrations and working implementations suggests that the future of quantum machine learning is incredibly bright.
All right, so we've covered a lot of ground here, from qubits to quantum transformers.
Yeah.
But before we move on, is there anything else in this first part of the paper that we should highlight?
Actually, yes. The paper goes into some detail about the potential benefits of using quantum computers for generative tasks.
Generative tasks. What does that mean?
Think about creating new data that has similar characteristics to the data you've trained on.
Okay.
Things like generating realistic images, composing music, or even writing stories.
Like a quantum AI artist.
Exactly. And there's been some really fascinating work in this area. For example, researchers have developed quantum generative adversarial networks, or QGANs, that use quantum circuits to generate data distributions.
QGANs. I feel like I'm learning a whole new language here.
It is a lot to take in, but the key takeaway is that quantum computers could have a transformative impact on our ability to create new and innovative forms of content.
This is blowing my mind, and I'm sure our listeners are feeling the same way. We've only just scratched the surface of this paper, and already we're talking about quantum computers that can break encryption, speed up searches, analyze data at unimaginable scales, and even create art. What else is in store for us as we delve deeper into this world of quantum machine learning?
Well, in the next part of the paper, we'll be exploring some specific examples of quantum machine learning algorithms that are already showing promise. We'll talk about quantum kernel methods, quantum support vector machines, and even quantum algorithms for anomaly detection.
Anomaly detection. That sounds incredibly useful.
It is. Imagine being able to spot fraudulent transactions or network intrusions before they cause any real damage.
Wow.
Quantum computers could potentially do this much faster and more accurately than any classical system.
I can't wait to learn more about that. But before we get ahead of ourselves, let's take a moment to process everything we've covered so far. We've learned about the fundamental building blocks of quantum computing, how quantum computers can achieve incredible speed-ups for certain tasks, and how these capabilities can be harnessed to revolutionize the field of machine learning. It's a lot to digest, but it's also incredibly exciting to think about the possibilities that lie ahead.
Absolutely. And as we dive deeper into this paper, we'll continue to uncover those possibilities and explore the potential impact of quantum machine learning on our world.
I'm ready for the next chapter. But for now, let's take a short break, and we'll be right back to continue our deep dive into quantum machine learning.
Sounds good. Welcome back. Now, where were we? Yes, the paper dives into some specific quantum machine learning algorithms that are already showing real promise.
You mentioned quantum kernel methods and support vector machines earlier.
Right.
I'm really curious to hear more about those.
Remember how we talked about quantum computers creating those powerful feature maps? Like projecting data into higher dimensional spaces where those complex patterns become much clearer.
Yeah, like finding constellations in a seemingly random scattering of stars.
Precisely. Researchers are using these quantum feature maps to build incredibly powerful kernel-based classifiers.
Right.
Imagine a quantum computer training a support vector machine,
Hmm.
or SVM, it's a common algorithm for classification,
Right.
and achieving even better results than with a classical SVM.
So quantum computers could help us make more accurate predictions, even in situations where classical methods struggle.
That's the potential. And it's not just limited to classification.
Right.
The paper also mentions using quantum kernel methods for regression, clustering, and even anomaly detection.
Anomaly detection.
Right.
Now, that's something I can really see the value in. Think about things like spotting fraudulent transactions or identifying network intrusions before they wreak havoc.
Exactly. Quantum computers could analyze patterns and flag anomalies with a speed and accuracy that leaves classical systems in the dust. It's like having a super-powered security guard for your data.
It all sounds amazing, but I have to ask,
Yeah.
if quantum computers are so powerful, why aren't we using them for everything already? What's the catch?
That's a great question.
Yeah,
And it highlights the reality of where we are with this technology.
right.
Building and maintaining quantum computers is a monumental technological challenge. It's not as simple as going to the store and buying a new laptop.
I can imagine. What are some of the hurdles that researchers are facing?
Well, one major obstacle is noise. Yeah, quantum computers are extremely sensitive to their environment,
Okay.
and any kind of disturbance can introduce errors into calculations.
So it's like trying to solve a complex equation while a rock concert is happening next door.
A very noisy rock concert, yes. This noise can really throw a wrench in the works,
Hmm.
and it's one of the biggest challenges researchers are working to overcome.
That makes sense.
Okay.
Okay, so there are practical challenges to building these systems.
Mm-hmm.
But let's get back to the exciting stuff.
Right.
This paper also talks about using quantum computers for generative tasks, which I find completely fascinating.
Yeah.
What's the latest on that front?
It's a rapidly evolving area.
All right.
We talked earlier about generating things like images, music, and even stories.
Right.
Well, researchers are making real progress in applying quantum computing to these creative tasks. One fascinating example is the development of quantum generative adversarial networks, or QGNs.
QGNs. That sounds familiar. Didn't you mention those before?
Yes, we touched upon them briefly. QGNs utilize quantum circuits to generate data distributions, essentially teaching AI to create new content based on patterns in existing data.
It's like a bit mind-boggling to imagine a computer, let alone a quantum one, being able to generate art or music that rivals human creativity.
It really is. And that leads us to another exciting area of exploration, quantum natural language processing.
I was hoping we'd get to that.
Yeah.
We've all seen what large language models like ChatGPT can do.
Right.
But what could quantum computers bring to the table?
Imagine those same capabilities, but amplified exponentially. We've talked about classical transformers being the backbone of those advanced language models.
Right, and how those models are already pretty impressive.
Well, researchers are exploring the potential of building quantum transformers.
Yeah.
The paper suggests these could analyze and understand language in ways that are simply impossible for classical computers. We're talking about AI systems that could truly grasp the nuances of human language, perhaps even surpassing our own abilities.
That's both exciting and a little unsettling, to be honest. The possibilities are mind-blowing, but it's hard not to think about the potential downsides.
I understand that feeling, but remember, we're still in the very early stages here.
Right.
It's crucial to have these conversations and consider both the incredible potential and the ethical considerations as this technology evolves.
Absolutely. So we've covered a lot of ground: quantum kernel methods, anomaly detection, QGNs, and quantum NLP.
Mhm.
It's a lot to process. Is there anything else in this section of the paper that stands out to you?
Yes, the paper delves into some of the theoretical underpinnings of quantum machine learning,
Okay.
discussing concepts like expressivity, trainability, and generalization.
Those sound pretty technical. Could you break them down for us non-experts?
Of course. Expressivity refers to the ability of a quantum machine learning model to capture complex patterns in data, essentially, how much it can learn. Trainability, as we've discussed, is about how easily we can adjust a model's parameters to make accurate predictions. And generalization is how well a model performs on new data it hasn't seen before.
So basically, we want quantum machine learning models that are powerful,
Right.
easy to train, and can accurately predict the future, so to speak.
Exactly. Researchers are making significant strides in all of these areas, but it's an ongoing journey.
This has been an incredible deep dive so far.
Yeah,
I feel like I'm starting to grasp the true potential of quantum machine learning.
good.
But where do we go from here? What are the next steps in this field?
Well, there are several key areas of focus. On the hardware front, we need to keep pushing the boundaries of quantum computing, building more powerful and stable systems,
Right.
and we need better error correction techniques to combat that pesky noise we talked about.
So bigger, better, less noisy quantum computers.
Precisely. On the algorithmic side, we need to explore new quantum machine learning architectures and develop more efficient training methods, especially in light of those barren plateaus that can hinder progress.
Right. Those flat landscapes that make training a nightmare.
Exactly. And finally, and perhaps most importantly, we need to bridge the gap between theory and practice. We need to identify real-world applications where quantum machine learning can make a tangible difference. We've touched on some examples, but there are countless others waiting to be discovered.
This all leads to a pretty big question.
Right.
What does this mean for me, for the average person?
Yeah.
How will quantum machine learning impact our lives in the future?
It's hard to predict with certainty, but the potential implications are vast.
Okay.
Imagine a world with personalized medicine tailored to your unique genetic makeup, where diseases can be diagnosed and treated with incredible precision. Think about financial markets that can predict and respond to economic fluctuations with unprecedented accuracy, leading to greater stability and prosperity.
Those are some pretty big promises.
They are, and they're just the tip of the iceberg.
Yeah.
Consider the possibilities for artificial intelligence. Quantum machine learning could lead to the creation of AI systems that can truly understand and reason. Systems that can help us solve some of the world's most pressing problems.
Right.
It's an exciting but also daunting prospect.
I can see that. The possibilities are both thrilling and a little frightening.
It's natural to feel that way. We're on the cusp of a technological revolution, and it's crucial to approach it with both enthusiasm and a healthy dose of caution.
Well said. This deep dive has been an eye-opening experience.
Yeah.
I feel like I've learned so much about a field I knew very little about.
And we're not finished yet. There's one more crucial aspect of this paper we need to address.
Okay.
It's not directly related to the technical details,
Right.
but it raises a profound question about the very nature of intelligence and the future of technology.
Intriguing. I'm eager to hear what this final aha moment is. What does the paper have to say about intelligence in the future? All right, I'm on the edge of my seat. What's this big question the paper raises about intelligence in the future?
Well, it's not explicitly stated,
Right.
but all this research leads to a pretty profound thought.
Mm-hmm.
Could quantum machine learning lead to the creation of truly intelligent machines?
Whoa. Okay, that's getting into some deep philosophical territory.
Right.
I mean, we've been talking about AI that can understand language, make predictions, even create art.
Right.
Isn't that intelligence in some form?
It certainly displays aspects of intelligence as we currently understand it.
Right.
But is it the same kind of intelligence that we humans possess? That's the core question.
Yeah, it's the classic debate about AI, right?
Yeah.
Can machines truly think?
Exactly.
And it sounds like quantum computing adds a whole new dimension to this question.
Exactly. These systems are fundamentally different from classical computers. They tap into this bizarre world of quantum mechanics to perform calculations that are simply beyond the reach of traditional AI. It makes you wonder, what are the limits of what these machines can learn and understand?
Could they, develop a form of intelligence that we can't even comprehend?
Right.
It's both fascinating and a little bit intimidating, isn't it?
Absolutely. It's like we're opening a door to a room full of possibilities, but we
Right.
have no idea what we might find inside.
Right.
It's exciting and unsettling all at the same time.
So what's the takeaway here? Should we be racing towards this quantum-powered future with open arms or proceeding with caution?
I think a balanced approach is key.
Okay.
You know, we need to explore the incredible potential of quantum machine learning while also recognizing those ethical implications.
Right.
It's not just about building powerful machines, it's about ensuring that we use this technology responsibly and for the benefit of humanity.
Couldn't agree more. This deep dive has been an incredible journey.
It has.
I feel like we've gone from zero to quantum explorers in just a few short segments.
Right.
But as we wrap up, what's the one thing you want our listener to walk away thinking about?
I think it's that quantum machine learning is a field just brimming with possibilities. We've barely scratched the surface, and the progress being made is truly remarkable. This isn't just science fiction anymore. It's a future that's unfolding right before our eyes. And the questions it raises about Intelligence, technology, and the future of humanity are ones we'll be grappling with for years to come.
That's a powerful thought to leave us with. Thanks for guiding us through this mind-expanding deep dive.
My pleasure.
And all our listeners out there, thanks for joining us on this exploration of quantum machine learning. Until next time, keep those minds curious and those questions coming.